Hello and welcome back. My name is Trung. I'm an amateur astronomer and astrophotographer based out of LA. And in this video, I'm going to show you how to process the Lagoon Nebula in SHO Hubble palette using only freeware, in particular DeepSkyStacker, Siril, and GIMP. These are all free, and I'll provide the links for you to download in the description below. If you visited my previous video, I did cover SHO Hubble Pilot in some details. So if you haven't seen that video, I encourage you to check that out to know a little bit about the Hubble Pilot. So we'll be using data from LCO, or the Las Cumbres Observatory, which operates a vast network of telescopes that covers the globe. And this is the website. The Lagoon Nebula is also known as M8 as the catalog, but we'll try using the new general catalog number, which is NGC 6530 for the object. Observation type will be expose, and the reduction level will be Banzai, which is the pipeline for applying calibration files, which you don't have to worry too much about. For the site, we'll select CPT, which is an observatory based out of South Africa. For the telescope, we're going to select the 0.4 meter size telescope. And there's no matching record found. That's okay. That's because we need to broaden the date range. So let's go back to the beginning of 2023. So January 1st, 2023 through, let's go January 1st of 2025. So we have more than 20 results. Let's just do 50 rows per page. And let's sort by filter. So let's click on these arrows for a filter. Let's make a selection based on the filter. So for the SHO Hubble palette, the S is for sulfur, H is hydrogen, and O is oxygen. In particular, the sulfur will be sulfur 2, which are these two here. So we'll click on the plus sign to look at the previews. You know what, let's also take a look at the previews for oxygen, which are these three. That's labeled O3. And we'll also do the same for hydrogen alpha. And the H alpha data, they all look consistent. There may be some variations with the exposure time. Here we have 350-second exposure and then a 500-second exposure. That's okay. We're still going to download these. The purpose of inspecting these previews is to make sure that the framing are generally consistent between the different filters, and they do appear consistent. So let's go ahead and download these one filter type at a time. So I'm going to collapse all of these previews. And then I'm going to check on the boxes for each of these filters. So we'll start with the sulfur 2 filter, which there are two of them. So we'll make these two selections, and you see the button for download 2. The 2 indicates the number of selections. So we'll click on the download button. Okay, our download has finished. I'm going to rename the downloaded folder by adding S2 at the end so we know that this is the sulfur data. And then I'm going to click on the X to clear the selected data below. Next, I'm going to check the boxes for the O3 data, which are these three here, and click download. The download is complete for the oxygen data, so we're going to rename the folder by adding O3 at the end so we know that the data is oxygen 3. Next, we're going to click on the X to clear the data that we selected. Then we're going to select the data for each alpha, so these 5 right here. Click on download. The download for H alpha data is complete, so we're going to rename the folder by adding HA at the end. Now that we downloaded all of the files, that we need. The next thing we're going to do is extract the zip files. So we'll do this one folder at a time. I'm going to extract the files for the sulfur data or the S2 data. Do the same for the oxygen data. And the hydrogen or HA data. So next, I organize my downloaded files by moving it to the folder that I want to keep them in. Then the next thing that we need to do is convert these files. So these files are currently fits.fz file. We need to convert these to fits files. And to do that, we're going to open Siril. Once Siril is open, you could drag and drop the files. So I'm going to highlight both of these sulfur2 fits.fz file and drop it in this window here. Then we're going to give it a sequence name. I'm going to type ngc6530 underscore S2 for sulfur2 data. I'll put another underscore there. And we're going to convert it to fits images. Click convert. So by clicking convert, this window here switched to the console tab. So let's go back to the conversion tab and click on this icon to remove all the files from the list. Next, we're going to convert the oxygen data. So highlight all three of these and then drag. For the sequence name, we're going to change the S2 to O3. So we're leaving the rest here, ngc6530 underscore, and then we're going to have O3 and then underscore. Click convert. Okay, and then switch from the console tab back to the conversion tab and remove all with this icon. And then we'll do the same with the hydrogen data. Drag all 5 of these, drop it in here. And then the sequence name will be ngc 6530 underscore HA underscore. Click convert. Okay, and all of the converted files will be in the pictures folder as default. And I'm going to highlight all of the files associated with the conversion that was done to the HA, the O3, and the S2 data. And I'm just going to put it back to the folder just to organize everything in one place. I'll put everything that's relating to HA to the HA folder here. I'll do the same for the O3 and the S2. Okay, next we're going to stack these images using DeepSkyStacker. Once you have DeepSkyStacker open, we're going to drag and drop the data. So we'll start with the sulfur data. Highlight the fits files and then drop it in DeepSkyStacker. And then we have to identify what kind of frame this is. In this case, these are light frames. Then click on check all and then register checked pictures. Click on the Advanced tab and make sure your start detection threshold is at the minimum. So that's going to register even less than ideal picture quality or image quality. Click on compute number of detected stars. It detected 669 stars for the registration. What this means is when you move on to the next process, which is to stack these pictures, there's a higher chance that all of the frames will be considered for stacking. Okay, and then we're going to stack the pictures. Then the next thing is to save this stacked image. I'll save it right in the S2 folder to keep things organized, and I'll name it ngc6530 underscore S2. Then the next step is to clear the list by clicking on this. Do you want to save the changes? No. And then let's move on to the next set of data, in this case O3. Highlight the fits files and then drop it in DeepSkyStacker as light frames. Check all and then register checked pictures. Go to advanced, make sure it's the lowest threshold. Click OK. And then click on stack check pictures. And then we're going to save the picture. Since this is O3 data, we'll go to the O3 folder, and I'm going to name it ngc6530 underscore O3. Then we'll click clear list. Do you want to save changes? No. And then we'll drop in the last set of data, which is the hydrogen alpha data. Check all, and then register pictures. And then stacked check pictures. Then we're going to save the stacked image under the HA folder. We'll call it ngc6530 underscore HA. And then close out DeepSkyStacker since we're done with it. Then let's go back to Siril. Let me clear the list here under the sources. Now we're going to use Siril to align all three of those stacked images just in case the framing is slightly off from one another. Okay, next we're going to drop in the stacked file into Siril. The stack file for HA would be this TIFF file here, so I'm going to drag and drop. And then I'll do the same for the other ones, S2 and O3. Okay, and then for the sequence name, I'm just going to have the name as ngc6530 underscore and click convert. Then click on the registration tab, and for the registration method, we're going to leave the default as global star alignment, and we're going to register the images from the sequence, and the sequence was from this conversion that we did here. So we'll click Go Register. And what this is doing is it's looking at all the stars for each of those stacked files. And if the stars don't align, it's going to align those files and then put them in the default folder, which is the pictures folder. And the files that are aligned would be the ones with the letter R in front of it. So it would be these three. Let's go ahead and copy the sequence file, and I'm going to put it back in the folder where I've been organizing all of these files. I'll just paste it right here. And by doing the conversion and the registration and the star alignment, we sort of lost information as far as which of these files are which filters. So one of these is for HA, and then another is for oxygen, and then the third would be sulfur. So to know which is which, we need to go back to the pictures file and grab this file here named ngc6530 underscore conversion text. I'll just copy that and put it back in my desired folder. Then we'll open it. And here you can see that the file ending with the number 1 is our HA data. So I'm going to rename underscore O1 to underscore HA. Number 2 is the S2 data. And the fits file ending 3 is our oxygen 3 or O3 data. So renaming it to O3 for that one. The next step is to stretch the stacked files in Siril along with star removal. So Let's drop in our sulfur data into Siril. Then you go to image processing, histogram transformation, and then let's try the auto stretch function, which is this icon here. This looks okay. We just want to make sure that we're not crushing the white levels, which would be, I would say this part of the nebula is the core or the brightest part of the nebula. What we want to avoid is something like this, where it's overly stretched. That might be an extreme example. Nor do we want to do a weaker stretch like this. We want more stretch to the image. So let's hit reset and do this again. So click on the auto stretch, and I think this looks good. So I'll click on apply, and then we'll do a star removal. So we go to image processing, pull down menu, and then star processing, and then StarNet star removal. We'll leave the box checked for generate star mask, and then we'll click on execute. This may take some time. It depends on your computer's processing power. If you have a gaming computer, this might run relatively quickly. Otherwise, this might take a while. Our StarNet removal has completed. So this will save the starless layer as well as our star mask in the default folder, which is the pictures folder. Here and here. So we don't have to worry about saving the data or exporting the data. It's already here in the pictures folder. So we'll go ahead and continue doing the same thing with our oxygen data. So I'm going to drag and drop the oxygen data. Then we're going to do an auto stretch with this icon here. Before clicking apply, it looks like the auto stretch may have overstretched the image based on what I see here at the core of the nebula. So let's zoom into the core here and drop the stretch by a little bit. Maybe somewhere around there. So I'm going to click apply, close, and then we'll do a StarNet removal, execute. All right, the star removal is completed. We'll move on to the next data, which is the HA data. So drag and drop, open. You might hear my daughter having a little chit chat in the background. Okay, now we're going to do an auto stretch on this data. The core might be slightly overexposed, so the white levels might be crushing just a bit. So this is the core of the nebula. So I'm going to back it down just a bit. So this is the detail that I wanted to preserve. I think this might be a good level. Well, let me see if I could stretch it just a little bit more. Maybe I'll back it down just a bit. I think this is good, so I'm going to click apply and then close. Then we'll do a star removal. The StarNet processing is complete, so now we have a total of 6 files in the pictures folder. I'm going to copy all of these and then paste it back in my desired folder. Next, we're going to open GIMP. GIMP is sort of like a freeware version of Photoshop. If you have Adobe Photoshop, you could use that. Otherwise, you could just download and use GIMP. So we'll go to Files and then Open as Layers. And then we'll navigate to the desired folder. And I'm going to select all the starless files. So that's going to be the starless HA. I'll hold down the control key to select the other ones, the starless O3 and the starless S2 files. Click open. We'll just click open for these prompts. And then next we're going to colorize these files. So for that we have to switch the mode from grayscale to RGB under the image pull down menu and then mode. Then we're going to switch the mode from normal to screen for all of these. The S2 is typically dark red. We'll just colorize this as red. So we go to Colors, pull down Menu, and then Colorize. Click anywhere in this box here, and then we'll change the values for the RGB. So the R will be 50, which is the midpoint, 0 for green, and then 0 for blue. Click OK, and then click OK again. Then we're going to colorize the oxygen data as blue. So that would be 0 value for red, 0 for green, and then 50 for blue. Lastly, we're going to colorize the HA data to green. So that would be 0 value for R, 50 for green, and 0 for blue. Now we've essentially colorized the data in the SHO Hubble palette. So from here on, we'll be making decisions based on subjective artistic preferences. So in this image at present, we see that there's a lot of red and some blue hues. I think we can bump up the green channel just a bit. So let's highlight the green channel, go to the colors pull-down menu and look for the curves adjustment. Then we'll put a point somewhere in the middle here to begin stretching. Maybe right around there, and I'll click OK to commit. Next, we'll make some curves adjustment to the blue channel. Select the blue layer and then go to colors and then curves. And we'll put a point somewhere in the upper tone of the curve. So here's the before, and then here's after as far as the preview goes. I sort of like the direction that we're going with this bump in the blue, so I'm going to commit by clicking OK. Then we'll move on to the red channel, so we'll click on this red layer and go back to curves. I feel like in the dark areas, which is here, here, and even here and here, there's too much red in the dark tones, so we'll put a point somewhere down here to bring down the red levels in the dark tones, somewhere around there, and then we'll add another point in the upper tone just to bring out the highlights somewhere around here. I think that looks good. So I'll click OK to commit to the change. Then we'll zoom in by holding down the control button and then scroll in and out with the mouse. Okay, I like where this is going. There may be some noise that we can fix in the red channel. The blue and the green channel is very clean. However, the red, there's a bit of noise, and I think we could just simply use the noise filter under the filters pull-down menu, go to enhance, and then noise reduction. Make sure your red channel or your red layer is selected. Let's bump the strength up from 4 to perhaps an 8. Let me bring the blue and the green back into view. I think that looks good, so I'll click OK. Okay, next, just looking at the overall picture, I feel like the core or the inner part of the nebula here is a bit hazy looking. And I think we can minimize the haze and bring out more details by increasing the contrast in this area. Now, I don't want to increase the contrast for the entire picture, just want to do it in this area, in this region. So for that, let's turn off the view for the red layer and the green layer. Then we'll click on this icon here for select by color. I have the threshold currently set at 49. We'll try using this value for now. And then we'll click on the brightest part of this blue layer, perhaps somewhere around here. the boundary here, it's a hard boundary. So we're going to soften that up by feathering it under Select, pull down menu, and then Feather. And I currently have it set to 600 pixels. We'll try using that value and see where it goes. Then we'll bring the red layer and the green layer back into view. Then we'll adjust the contrast with this brightness contrast tool. Check on preview, and then let's bump up the contrast. So here's the before and here's after, and I sort of like where this is going, so just do one last check here. I'll click on OK to commit to this change. Okay, and then let's clear our selection by going to select and then none. Then we'll go to the green channel and see if we could make some adjustments with the brightness and contrast tool. Now, this wouldn't be a good approach. You could see here that the core of the nebula, which is right here, would become overexposed if I were to proceed with this change. So what we're going to do is uncheck the views for the red channel and the blue channel, or layers. And then we're going to use the Select by Color tool and click on the brightest part of the green layer. Then I'm going to feather it. Instead of 600, let's try 300. Okay, and then I'm going to invert the selection. So instead of making changes within the core, we're going to be making changes outside of the core. We'll bring the red layer and the blue layer back into view, and then let's go back into the brightness and contrast tool. Check the preview, and then play around with the contrast. Let's bump up the brightness. So here's the before and here's after, and I sort of like how this is looking. Just want to do one final check. Okay, so I'll commit to this change. Okay, let's see if I could further enhance the core. So I'm going to switch the selection back to the core itself by inverting it again. Okay, and then I'll bring up the curves tool. Perhaps I'll put a point here, commit to that change. Let's see if we could make some further enhancements to the core with the red channel or the red layer. So let's select the red layer, go back to the curves, maybe a point somewhere around here. Uncheck the box for preview to see the before and check it to see the after. I like how this is looking, so I'll click OK to commit. Okay, I feel like the core has too much of a purple hue that's going on here, so I could reduce the purple by going back to the blue channel or the blue layer, and we'll use the curves tool, and then I'm just going to drag down the upper end of the curve. Let's turn on the preview here, maybe somewhere around there. And then let's go back to the contrast, maybe somewhere around there. I'll click OK. Then I'm going to bring the red channel down quite a bit for the core by using the curves function, and I'll drop it maybe somewhere around here. Here's the before and here's after. So before, there's still too much purple in my opinion, and then right after, that purple is attenuated, so I sort of like the looks of this. I'll click OK to commit, and then I'll remove the selection. So remember, the selection is still there, so any changes in the next step would only impact the selected area. So let's go ahead and remove that. Now it's time to add the stars. To do that, we'll go to Open as Layers, and then we'll select all the files with the word star mask in it. I'll press and hold down the Control button and select multiple files. So these are the ones here that we need. Click Open. What I tend to do is I like to move all of the star masks to the bottom of the list here. Let's go ahead and turn off the view for the nebula, and let's inspect the stars. Well, let's look at these one at a time. This is the star layer that's captured by the hydrogen alpha filter. That's by the O3 filter, and then this is by the sulfur filter. I'm not too fond of the way the stars look in the sulfur data because for a couple of reasons. One, there's too many stars here that would distract from the image of the nebula. The other problem is the stars are quite fuzzy, so not quite the best data to be using. So let's get rid of the sulfur data. So left click, delete layer. Now we're down to two star masks, the HA and the O3. Get a closer look here. I think the HA might be the best data for the stars, but let's go ahead and add back the nebula. And by the way, we're not going to colorize the stars. I feel like if we ended up doing that, it's going to give a purplish hue, which is quite common if you colorize stars where the stars were imaged through the SHO filters. If the stars were imaged using the RVG filters, then the stars would tend to look more natural, but we don't have that type of data in this case. So that's one reason why I'm not going to colorize a star. The other reason is I want the stars to remain to not pop in colors because the intent of this image is for the nebula to be showcased, not the stars. But I do like the way the O3 stars look, so I'm going to get rid of the HA layer for the star mask. And I think this is complete, so I'm pretty happy with the results of this processing. So I'm going to export, and I'll call it NGC 6530 finished, or final, I should say. Instead of fits, perhaps JPEG. And the default quality is 90%, which is fine. Or you could do 100%. Let's keep it at 90. That would make the file size quite manageable if you wanted to email it to your friends and family or post on social media. I'll click export. And here it is. It's about 10 megabytes, so that's a good size for posting on social media and emailing. And there we have it. The final image of M8, or the Lagoon Nebula, using free data from the Las Cumbres Observatory archive. So a special thanks to Las Cumbres for making the data available to the public to download, along with millions of pieces of data that they offer for the public to download. Anyway, I hope you find this video to be helpful and informative. Again, this is just a basic tutorial for beginners to get started on downloading and processing data to an aesthetic pleasing image while preserving scientific data. So thanks again for tuning in and following along. This is your host Trung, wishing you the best. Take care and keep looking up. Bye-bye.